Hey everyone, in this video we're going to be transitioning in the course into trigonometry, and this can be its own course actually, but it is put together with our pre-calculus skills. It's a really wide-ranging topic. So it began, this topic of trigonometry, it began actually used in the development of astronomy, navigation, surveying, and construction. I mean, like, we're talking early stages of mathematics. Astronomers used it, as well as people who were sailing ships and just surveying the land. This video, I want to say this to begin, I've restructured the format of this video. Typically we had the check for understanding at the end of the video. So you went through the whole video, or some of you just skipped to the end and just did that problem. The check for understandings are actually put in throughout this video because I am throwing a lot at you here for the first couple of videos while we get used to trigonometry. I just want you to know that it's throughout the video that you're going to be pausing, doing problems, asking questions of that sort. Okay. Now, when we talk about trigonometry, we know it's the measurement of triangles. That's what it began with. So if we're talking about triangles, and we're eventually going to talk about circles, it's good for us to know about angles and their measures. And in the early stages of trigonometry, they used mainly one form of measurement with angles, and that is the degree measure. This is the one that we're most familiar with. You've worked with this a lot in geometry. We know that we utilize the symbol, the degree, and we know that. So one thing we want to note is when we say 1 degree, what that actually means is that the 1 degree is equivalent to 180th of a straight angle. Okay, so we get 180th because 180 degrees is a straight angle. We know that from geometry. So speaking to the degree, what a degree is, there are two forms an angle measure can be written. Okay, so I'm throwing a lot at you, so this is kind of our first chunk. So we are familiar with this first form. Color. We are familiar with what's called the decimal degree system. Okay, and we're going to abbreviate this by using just DD, decimal degree. This is the typical. Okay, we often just say that this is just the degree. Typical. So, you know, some examples of this form: 47.552 degrees, 62 degrees, 90 degrees, 124.1 degrees. This is the form that we're most comfortable with. This is the form that we get from our graphing calculator. It's the decimal degree system because, again, it's decimal degree. The one that we are most probably unfamiliar with is what's called the degree minute second system. Or we're going to abbreviate this DMS, degrees, minutes, seconds. So this system, why this system was created or where it's used, is this is often used in navigation, okay? So when we talk about bearing or talking about a course being set, the angle measures are often seen in this format. And what we have to know here, first of all, is that each degree is subdivided, meaning is made up of, subdivided into 60 minutes. So if I were to write that down, it's 60 minutes. We're using a little one tick mark. 60 minutes for every 1 degree. Okay, then the next, that's the minutes. The seconds is each minute is subdivided into 60 seconds, and that should make sense. We're used to that. So 60 seconds, we're going to use 2 tick marks for every 1 minute. Now this might seem, this might not seem much sense, but to kind of give you just a basic generic example, if I were to take an angle measure that's in decimal degree form, say 76 point something, where we have a degree and we have the decimal, the degrees, minutes, seconds, it's going to take this 76 and the decimal. It notices the 76 still, but what it does is it takes the decimal and it converts that decimal into minutes and seconds. So it would look like this. So we'd have like 3 numbers: degrees, minutes, seconds. So going from one to the other. So how do we actually go from one form to the next? So I have some examples here. So let's say we want to convert the angle measure 37.425 degrees to our decimal, our degrees, minutes, seconds form. Okay? So if the first thing we do is we examine only the fractional part. So in this situation, only the fractional part would be the 0.425, okay? And we convert that to minutes and seconds. How do we do that? Okay, well, by the way, the reason why we don't take anything with the 37 is at the end of all of this, we're gonna have, you know, degrees, minutes, and seconds. So I already know what my degrees are. We're essentially finding what the minutes will be and what the seconds will be if our decimal is 0.425. So what we do with this 0.425 is we just saw that for every 1 degree, it is 60 minutes. So if you're used to converting units, you know that in order to change units, the common units have to be on a diagonal. So we know for every 1 degree, it's 60 minutes. So we multiply. And when you multiply 0.425 times 60, we get 25.5, and that's in minutes. So what I take from that, we just repeat the whole process. So we now repeat again with the fractional part, which is 0.5. So 0.5 minutes, and we're converting that to seconds. So far, we know that 37.425 degrees is 37 degrees, 25 minutes. And how many seconds? Well, we take 0.5 seconds, and we know that for every 1 second, for every 1 minute is 60 seconds. We're going to be multiplying the two. So 0.5 of 60, or half of 60, is 30. And there we go. So 37.425 we examined the fractional part and converted it, and then converted it again. We know that this in decimal degree form is 37 degrees, 25 minutes, and 30 seconds. It's just another way of representing the fractional part of an angle measure. So this is our first, the first in this video where we're going to check for understanding. So previously I would say that this is the your turn. So I'm going to give you this example, and you're going to pause the video, work on it, and check back in with the notes and see how you did. So let's say I want you to convert 3.58 degrees to degrees, minutes, seconds. So pause the video. Using the example I provided, go ahead and do this. Okay, so you should have found that converting 3.58 degrees, it is 3 degrees, 34 minutes and 48 seconds. How'd you do? So when you come in, we're going to be practicing this more. But what if the question was rather... I lost my pen. But what if the question was rather convert 42 degrees, 24 minutes, and 36 seconds to degrees, or decimal degrees? How could that be done? Well, let's see. We know 42 is going to be our degree, so we essentially do not know the decimal. And how we find this is we're going to use our understanding. This is minutes, so this is essentially 24 out of 60. Okay, and then the 36 minutes is 36 of, there's 36 seconds. The 36 seconds is of a minute, so that's, and the minute of a degree, so there's two 60s here. And I'm going to just place this into the calculator. And when we do that, so 42 plus 24 over 60 plus 36 over this, we're essentially just placing this string in, we get 42 degrees, or 42.41 degrees. So let me explain this again to you. We saw earlier that every 1 degree is 60 minutes. So the minutes, when I'm converting back to degrees, the minutes I'm going to divide by 60 and add that on to the whole degree. The seconds, we know that 60 seconds is 1 minute, but it took 60 minutes for 1 degree. So you have to see there's two 60s there, hence the two 60s in this. So and we take each of those fractions and add them back onto the whole degree. So to check for understanding, another check for understanding. I would like for you to convert 85 degrees, 18 minutes, and 30 seconds to degrees. So we're going to pause this video. Okay, so in converting our angle measure to degrees notation, we found that we get 85.30833 repeating degrees. Again, just breaking this up as they already did for us and knowing what we divide each number by. And that is how we go from DMS to our decimal degree. So we're going to be jumping to yet again another area of angle measures. So I said at the very beginning of this video that trigonometry began and it was utilized in surveying, it was utilized in constructions, it was utilized in navigation and in astronomy. But with the development of calculus and technology and other things, trigonometry eventually began being utilized in other areas. So this was with the advancement of calculus. Trigonometry was used when examining rotational motion and sound waves, and that's just two of a huge list of areas where trigonometry is now used with the advancement of our math techniques. So with this advancement, this requires a new form of angle measure. Okay, and the reason why that it requires a new form is there's an issue with the degree. There currently is no way to compare an angle measure that's in degrees to the radius of a circle or arc of a circle, and which by the way, I should say this, with this whole advancement, we see degrees mainly in triangles and applications in engineering and whatnot. We're now examining trigonometry with circles. Should have said that. So when I just said, comparing an angle measure in degrees to the radius of a circle, an arc of a circle, that's why, because we're now focusing trigonometry within circles. We can't compare a degree to a radius that's in inches, feet, miles, centimeters, kilometers, whatever. So the solution to that, the solution to this is a whole new way of measuring angle measures. And that new way is the radian measure. And I believe we have seen this before, maybe in Algebra 2. I believe we should have seen this before in Algebra 2. Maybe not. So what this radian is, we saw earlier a degree is 1/80th of a straight angle, because that related it to a geometric sense. Here, what a radian is, it's a central angle of a circle. Has measure, or a measure, however you want to say that, has a measure of 1 radian. Has a measure of 1 radian if its intercept or if it intercepts, there we go, if it intercepts an arc with the same length of the radius. And you're reading that, you're thinking, what? So remember, we're dealing with circles. So if I were to draw a circle, that is a beautiful circle. Oh my goodness, look at that. That's like very close to perfect. So if I have a circle, a radian is the measure of an angle when its arc is the same length as the radius, okay? So when that occurs, when the angle measure provides an arc of the same measure as the radius, we call this 1 radian. That is what a radian is. All right, so a radian is an angle measure that makes its arc, that has an arc of the same length as the radius. Okay, well, we know that there are 360 degrees in one circle, right? So yeah, we know that 360 degrees is 1 full revolution. That's in degrees. Well, how many radians are in a circle? I mean, you might know this. If you've seen radians before, you probably know the answer to that question. Let's think of a couple of things here. So in geometry, it's been, well, for some year or two, we know that the angle measure within a circle can be found by dividing the arc length S by the radius. So I'll write arc length and radius. Okay, so if I take the arc length and divide it by the circle's radius, I will get the angle measure of that arc. So keep that in mind. By the way, this theta, we're going to be in radians here. So, in degrees, 360 is a full rotation. Well, we're talking about arc length. 1 full rotation, or revolution. 1 full revolution, we also know that that distance, we know to be something called the circumference. So, which again, so the arc length, that length will be 2 pi r. We should be familiar with that. So let's think for a moment. If I'm looking at an angle measure in radians, remember, in radians, we said it's the arc length divided by the radius. The arc length divided by the radius of the circle. 1 full rotation, revolution, the arc length is 2 pi r divided by the radius, and we get r's canceling, we get 2 pi. And you might not realize what we have here. What we have is there are 2 pi radians within one circle. So 1 revolution is 2 pi radians. And yes, you can multiply 2 times pi and get 6 point something. But we actually leave radians in terms of pi. In terms of pi, is simply pi is going to be in all of the measurements with radians. So every time you see a measure in radians, you often see a pi there with it. So we're going to make a little table right now. So we just found that 1 revolution, which we knew to be in degrees 360, we just found that 1 revolution is 2 pi radians. So we're going to use that to complete a little chart here. So what if we had a half revolution. So we know in degrees that's 180 degrees. We divide it by 2. So if we divide 2 pi by 2, we get pi. So a half revolution, 180 degrees, is in radian measurement just 1 pi. So okay, let's say we have a quarter revolution. So a quarter revolution, dividing 360 by 4, we get 90. So I might have to write this down. So 2 pi, a quarter of that, 2 divided by 4 is 2, or 2 divided by 4 is 1/2. So we get 1/2 pi, or just pi over 2. And let's say we have a 6th rotation, or revolution. So 360 divided by 6, that is 60 degrees. So 2 pi divided by 6. 2 divided by 6 is a third. So instead of writing 1/3 pi, which we could write pi over 3. And I wanted to say this because I feel like this could be a common misconception. The pi here is not the units. So in degrees, we have this little circle to write for an angle measure in degrees. When looking at an angle measure in radians, we actually have to write radians out. That is the unit of measure. So we're seeing a bridge here. We're seeing maybe a pattern you're noticing going from degrees to radians, but this is where we kind of bring this video to a close. We're going to make a bridge between angle measures in degrees in one form and radians. Okay, so let's say we have our two forms an angle measure could take. And how do we go from one to the other? Thankfully, there is this nice formula that we can use to go from degrees to radians, radians back to degrees. So let's say I want to convert degrees to radians. If I want to do that, I multiply my angle measure by pi over 180. And in simplifying, I'll get my angle measure in radians. So let's say I want to go in the opposite direction. So I want to go an angle measure that's in radians to degrees. Well, here we multiply by 180 divided by pi. So we multiply what we have here, and what we get as a result is our angle measure that's in degrees now. So this is going to be a great visual for us to kind of memorize, to keep hold of as we go throughout this whole entire chapter, because this is going to be used without trigonometry. So I'm going to go through a couple examples with you just converting from one to the next. So let's convert 135 degrees to radians. So I'm in degrees, I'm going to radians. So according to this, I multiply by pi over 180 degrees. Notice how my units that are common are diagonal to each other. One's on top, one's in the bottom. So we do this, 135, I'm going to divide that by the 180. I just put pi to the side because pi is going to stay there, remember? And 135 divided by 180, when you do that calculation, you get 0.75, which it's kind of tacky to write a decimal and then pi. We often want to write our results as a fraction. So you get 0.75 or 3/4 and pi radians. All right. So what about 1/8 pi radians we want to convert this to degrees. So how do we do this? All right, so we have 1/8 pi, multiply by 180 over pi. And what's really nice, and you'll see this here soon, we multiply the two. So I get 180 times pi, really don't want to mess with that. And I get 8 times pi. Hey, there's a pi in the numerator and a pi in the denominator, so they cancel. That's actually going to happen. So when I'm converting from radians to degrees, since radians are often in terms of pi, these pi's will cancel, leaving me with just 180 divided by 8 here. And when I simplify that, degrees can be in decimals, as we saw at the very beginning. 22.5 degrees. All right then. So to close out this video, our last check for understanding. Convert 240 degrees to radians and 5/6 pi to degrees. And as always, the solutions are in the notes that are attached, so you can easily check there. I'm not going to post them on this video to make it a little shorter, but I threw a lot at you, a lot about angle measurements that we need to know, going from decimal degree form to degrees, minutes, seconds, knowing what a radian is, and knowing how to convert from a radian measure to a degree measure, and really it's just two forms of writing an angle measure. So we're going to continue here examining trigonometry. First, we're going to look at trigonometry within triangles, and then we're going to expand further, looking at trigonometry on circles. Okay? So as always, post your questions, comments, and we'll get those questions answered before you come in.